start from the basics and go in depth on query store. And if you want to see the extended version of this session, please go ahead and look into the dbanuggets.com, where I will be explaining in depth and extension version of this session. So before beginning, I would like to thank Gavaskar for giving me this wonderful opportunity. I didn't know many, I didn't know that you guys offer so many things like certificate for the attendees and all the things. So I'm so honored to be here. So let's get started. A little bit about me. I'm a database administrator having several years of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University here in United States, Chicago. And I'm also organizer for a couple of user groups. I'm an organizer for diversity, equity, and inclusion user group, and also Microsoft Data and AI South Florida user group. I do volunteer for Women in Technology user group as well. Apart from my work and my community work, I love doing arts and crafts. If I make something with my own hands, that gives me so much peace. And if you would like to contact me later, if you have any questions that you did not get the answer in this session, you can contact me on Twitter at dbanuggets or on LinkedIn, and my website is down below. So let's move forward with the session. What are we going to cover in this session today? If you're not familiar with the query store, we are going to talk about the introduction. What are the query store benefits? And what are certain benefits, like plan forcing is the primary benefit of query store. But once you force a plan, you can't sit there and then think like it will take care of its own. There are certain failures that might be caused if you are doing certain things that we are going to discuss in the session. We are going to see why we see those failures and how to capture them. And the automatic plan correction, which is available in Enterprise Edition of SQL Server. We are going to talk about that, and we have a demo. And we are also going to talk about the query store hints, which is in the preview mode. And also, I added a slide of what all enhancements we are going to see in SQL Server 2022. Most of this session will be demo based, but what I do not want to go back and forth between the slides and the demo. So I will complete the slides first and then go and take care of the demo. So what is Query Store? Query Store is a feature that got introduced in SQL Server 2016. So basically, it's not a server-wide feature, which is automatically enabled. It is a database level feature. So it is not disabled. It is not enabled by default. If you want to enable, you need to go to the properties of the database and you have to manually enable the Query Store. Once you enable the Query Store, well, as soon as you enable, and depending upon the options that you choose, the queries will be captured, like all the information of your query execution, like the query text, query ID, execution plan information, resource consumption information. All of this information will be captured within the query store. So where does this query store data gets captured? It is captured in the primary data file of the database where you enabled it. As this is a database level feature, it can be only enabled on the user databases, but not on the master or Dmdb databases, system databases. And you cannot change the location of where the query store data will be captured. It is always stored in the primary data file location, and you cannot change it. And it is enabled by default on Azure SQL database, and you cannot disable that. And it is disabled by default on Azure Synapse Analytical Database. This is a very, this is a very important discussion that I'm going to talk about how Query Store actually works. I know this slide seems to be like confusing and overwhelming, but let me explain in a very simple words. Whenever a query, right, anytime a query is submitted to the SQL Server, the first thing that is being checked is this query is running for the first time? If the query is running for the first time, then obviously it will go through the compilation and the optimization phases. If it is not running for the first time, well, it will go ahead and check if there is already a plan available in the cache. If there is no plan, let's say we cleared out the DBCC free proc cache or we deleted a couple of the plans from the plan cache, right? Then in that phase, again, it will go through the compilation and the optimization phases to build the execution plan. But let's say there is a plan associated for the query, right? Then all right, it will go ahead and take that plan from the cache and move forward with that. But wait, before moving forward, it will check for the recompilation. Any query after being taken the plan from the plan cache, it will go through the recompilation. It will check for the recompilation. So what will happen during that phase? Let's say we have a query and we enable the query store on the database and we forced a plan. So a particular query that we are running now has a forced plan. So it will go ahead and check if there is already a plan that is similar to the forced plan. If there is already a plan in the cache, it will go ahead and check, well, is it similar to the forced plan? If it is similar, then go ahead. If it is not similar and it created a new plan, it will go and check if it is similar to the forced plan. Well, it is not similar. If it is not similar, then it will go ahead and apply the forced plan, meaning it will create a plan similar to the forced plan. Okay, and let's say it is similar to the forced plan already, right? There is a plan in the cache which is exactly similar to the forced plan. Then, well, it will move ahead. Now, before going into the execution phase of the query, the query text and the query plan information will be saved in the plan store. You might be thinking, what is this plan store, right? So whenever you enable a query store on the database, there are three stores that will be captured in the memory. One is the plan store, runtime stat store. Runtime stats information will be also stored in the memory, and plan store will be also stored in the memory. So before the query goes to the execution phase, the query text and the query plan for that query is captured in the plan store of the memory asynchronously, and this process will happen asynchronously. And then the query goes to the execution phase. Once the query executes, because runtime stats information is the information that will be only captured after the query gets executed. So that information will be also captured in the runtime stat store in the memory, and this process will happen asynchronously. And once the interval has been reached, meaning like when you enable the query store, you also have to include certain options where you also choose what interval you want. So this interval meaning like all the captured information in the memory, like the query text, query plan, runtime stats information, this information after hitting that interval, it will be flushed out to disk. So it will be flushed out to query store schema. And this process happens asynchronously as well. And remember, always the query store schema information, all the captured information will be only stored on the primary data file of the database. You cannot change that. We have seen how the query store actually works. You might be having a question like, okay, but our query information, query plan information will be already captured in the plan cache, right? So why do we have to enable query store? What are the advantages, right? Let's see the difference between the plan cache and query store. Like whenever you restart the SQL Server, you know that your plan cache will be flushed out, right? It will start from the scratch. But with the query store, all the data that has been captured by the query store will be retained. And it will be retained until it hits the cleanup policy. And the cleanup policy is by default 30 days. You can go ahead and change that. And in the plan cache, we can see the latest plans. Because, whenever there is a memory pressure, the first thing that will happen is that the least recently used execution plans will be flushed out from the plan cache. That's the first thing happens when there is a memory pressure. And you can only see the latest plans in the plan cache because the oldest one will be deleted first. But with the query store, as it will collect the information over time, you will have the all information of the query along with the resource consumption information. And the first thing that happens, like we discussed, the plans will be evicted from the plan cache whenever there is a memory pressure. But with the query store, until the flush out intervals has been reached, all the data will be in the memory. Let's say the flush out interval you have placed as 15 minutes, let's say. All the information will be flushed out to disk, which is the query store schema, which is in the primary data file, every 15 minutes. But sometimes, whenever there is a memory pressure, it can flush out to disk even before hitting that limit, that flush out interval. Just keep that in mind. And it is very difficult to know why the plan has changed if you are going ahead and looking into the plan cache, right? But with this query store information, as it collects all the execution plans over time, along with the resource consumption information, it is very easy for you to troubleshoot the performance problems with some little clicks. You can go ahead and see what are the top resource consuming queries and what are the execution plans over time. You can compare the execution plans and then choose which one is best, and then you can force it until you go ahead and manually fix the query by working with the developer or the other DBAs. Now, what kind of data is collected once you enable the query store? Before, before SQL Server 2017, there is this 2016, right? If you are in SQL Server 2016, wait stats information is not included because that information is included from SQL Server 2017 plus and above. It will be collecting all the information like query text, query ID, CPU, IO, memory, all the information. I do not want to read out loud, but all the information that you see here, whatever information you need to performance tune your query, all the information is captured here. And as you can see the history of the plans over time, if most of our queries are using just one plan, but then there is another plan just being created sometimes or the other, you can go ahead and compare. Why is it actually creating a new plan? Is there a parameter sniffing problem here? And how do I fix that problem? Right? In a single GUI mode where you like it is a graphical user interface. You can either use the graphical user interface or you can check the query store captured information by querying the views, by querying the catalog views. So what are the operation modes we have? Once you go to the properties of the database, you can enable by using these operation modes. You have three operation modes. Off meaning like it's like shutting the doors of the query store. Nothing will happen here. Read only meaning it will just read the information and use the information if you already have a forced plan. Let's say you are in the read write mode, but then for some reason you do not want to capture anything else. You wanted to go ahead and change that to read only mode. Once you change to read only mode, do not worry about the queries where you already forced a plan because the read only mode will read that information and use the force plan information. There is no problem with that, but it will stop capturing any new information coming in. With the read write mode, it will read as well as write all the runtime stats information and all the resource consumption information as well. And the recommended operation mode is always read write. What are some of the capture modes? So you went ahead and enable the query store, right? Read write mode, and that is not enough. You need to go ahead and also choose how do you want to capture your queries. Whether you want to capture all of the queries, then go ahead and choose all. But this is not recommended. In SQL Server 2016, all is the default mode, but it is not suggested. If you have SQL Server 2016 and you are as it is the default mode, it will be on all. please go ahead and change that to auto. Now, why I say that, right? Because if you choose the option all, it will go ahead and even capture all the insignificant queries, ad hoc queries, insignificant queries that you are not even bothered about, right? They run pretty fast, and we do not want to mess up with the query store data, right? We don't want to capture each and everything and then lost in the amount of data that we capture. So change that to auto. But what will happen if you choose the option auto, which is recommended by Microsoft? So when you choose the option auto, internally there is an algorithm. It is not published in Microsoft Docs, but internally the query should run certain amount of times, as well as it have to hit a threshold of CPU compile time to be captured in the query store. That will happen when you choose the option auto. If you choose the option none, you will stop capturing any new information. But if you already have any forced information, it is being used. Do not worry about that. Even if you choose here none, existing data will continuously um, will be continuously gathering the information. Like let's say you already captured a query, right? And then you choose the option none. It will continuously capture the data for that particular query, but the new queries will not capture any information. Let's say you have certain queries, you are only bothered about those queries, right? So capture those queries and then go ahead and change it to none so that any new queries will not be captured, but still capture the existing queries. What will happen if you choose the option custom? You can go ahead and customize the capture policies here. You can go ahead and choose when you want the threshold to hit and what should happen after the threshold hits. Let's talk about the query store options. But before that, Gavaskar, do you have any questions in the chat window?
No.
Okay.
Yeah, you can
So
proceed. Hmm.
sure. So let's go ahead and talk about the query store options. Now there are several options that we need to talk about. Most of them I'm going to talk in our demo. Yeah, I'm going to talk in our demo. Couple of very specific options, but let's talk about the general ones here. The cleanup policy, like it's by default, it will capture 30 days of information, and you can change that. Data flush intervals in seconds is 15 minutes by default. So all the information that is being captured, like the query text, query ID, and runtime stats information in the memory, right? So after reaching the 15-minute interval, it will be flushed out to query store schema. Sometimes when there is a memory pressure, it can flush out to disk even before hitting that limit. Max storage size is by default 100 MB, which is very little, right? If you're capturing more information. For SQL Server 2016 and 2017, 100 MB is a default, so you need to go ahead and change that. And for 2019, they thought it is too much, 100 MB is too much, so they made is like way too little, 100 MB. So they changed that to 1 GB for SQL Server 2019. Again, for the complete list of all the options you have, please follow the Microsoft Docs down below. So what are the query store benefits? Like we discussed a couple of benefits, like plan forcing is one of the major benefit, but we also have the other benefits. So once the query store captures the query information, execution plan information, you can go ahead and identify the regressions between those execution plan very easily, because you can just by using little clicks, you can compare the execution plans side by side and then think about plan forcing. One of the major benefits is a plan forcing, right? So you can very quickly fix the problem, fix the performance issue problem by forcing a plan. It is very useful for the performance tuning. Now, when I say that plan forcing is a major benefit, it's not like you force a plan and then forget about that, because once you force a plan, today it is working optimally. But tomorrow, or 6 months later, or 1 year later, the same execution plan might not be working optimally because it's an OLTP system. continuously add the data, and we add the indexes and we drop the indexes and we do multiple things, right? So there is high chance of it going ahead and creating new execution plans, and they can be optimal when compared with this plan. So once you force a plan, you need to take care of monitoring those plans, whether they are still valid or whether you need to go ahead and change it. And by using the plan forcing, you do not have to change the underlying code. All you have to do is like click on the execution plan and then force it. Personally, we implemented query store not only for the plan forcing, but for the database upgrades to capture the baselines after the database upgrade. So let's say we have SQL Server 2012 systems and we migrated those databases to 2016 and above. Well, 2012 doesn't have query store, right? So we have certain queries that are performing really well. And once we migrate it, we still place the database in 2012 mode on the newer systems just to capture how they used to work, right? We migrate the databases instead of upgrading the database to 2016. We made sure they are still 2012 mode, compatibility mode, enable the query store, run our queries. Once we are good with running all of our queries and capture all of that information in the query store, we then enable the queries. We then upgraded our database to the newer compatibility mode, which is 2016 in my example. And then run our queries on the 2016 mode, which is the upgraded mode. Most of the time, our queries run pretty fast in the newer upgraded mode, but there are always certain queries, right? After upgrading, they stuck. So in that situation, you can go ahead and see, okay, how this query used to work in 2012 mode, and what is the execution plan for it. You can directly go to the query store of the database, of the upgraded database, and see the history of that execution plan, and then simply go ahead and force it. And we are going to see that in our demo as well. So there are three stores like we discussed. Plan store will store obviously the execution plan information. Runtime stores will store runtime stats information, and wait stat store will actually create categories for the wait stats information, and it will store in the schema. Let's talk about the plan forcing. So plan forcing is similar to the use plan information. But to use the use plan, you need to edit the code, like let's say a store procedure. You need to go ahead and change the code. But by using the plan forcing, you can simply use the views to go ahead, and you can simply use the GUI to with the simple clicks you can go ahead and force a plan. And there are several reasons why the forced plan can fail, right? Even if it fails, do not worry, your queries doesn't fail. Your queries will work pretty fine. So all it will do is it will go ahead and check, hey, is there a force plan for this? Remember we discussed in the how query store works, it will check for the recompilation, right? So it will go ahead and check if there is a force plan in the plan cache, at least similar to it. And if it doesn't find, then it will create a new plan. But then how do we know that it is what is the reason of creating a new plan, right? So it will go ahead and save that information in the query store as well. Why it has actually created a new plan. Are there any failures? And what is the reason for the failure? Right? We are going to see that in our demo as well. So to force a plan, you can either use the graphical user interface, or you can run this particular store procedure, SP query store force plan. GUI is easy, right? We can use the GUI, but it is not recommended. Now, why? Is because if you use graphical user interface, that information like who changed what, who forced what query, you cannot capture that information by using your tools like monitoring tools. But by using this particular store procedure, you can easily capture that information. because it is simply a stored procedure, and that information will be captured in the monitoring tools. And you can also unforce a plan, again, the similar way graphical user interface, or by using this particular store procedure, SP query store unforce plan. Let's talk about the failures. Again, let's say there is a query that you already forced a plan, right? Let's say that particular forced plan have certain indexes in it. And then without your awareness, you have forced a plan, but without you knowing, some other DBA, he have the rights, right? So he pulled up a report and he found this particular index that is being used in your forced plan. He got a report saying that that particular index is being unused because your query doesn't execute a lot of times. It only executes certain amount of times, and your other DBA thought, okay, this is an unused index, let me go ahead and drop it. So he dropped it. You are not even aware of it. But then when this query runs, right, it will go ahead and check for the force plan. Now, when it checked for the force plan, that particular index within the force plan is not existed. So it thinks there is no plan associated with this query because the forced plan have that index which is not there now. And then it will go ahead and create a new execution plan. It will go through the compilation and the optimization phases, and it will generate a new plan and it will use that plan. And you are not aware, right? And then one day, one fine day, you'll go ahead and see, oh, well, I forced a plan, but why did it created a new plan? What's going on? And you'll go ahead and see the force plan information, and you'll find there the alert, like the error. What is the error? So it can show you the no plan error, no index reason, or why your post plan has not been used, right? But remember, your queries doesn't fail. All it does is create a new execution plan and it will use it. So you can monitor these failures by using the graphical user interface. Once you enable the query store on the database, it will create a query store folder underneath the database. So once you expand the query store folder, you see the queries with force plan. That's where you'll find the reasons of the failure, why it has actually not chosen the force plan, and why it created a new one. You can also do that by using the system catalog views. This particular query I have captured from the Microsoft docs down below. So let's talk about the automatic plan correction, which is especially the enterprise edition of SQL Server. It is available for SQL Server 2017 and above. So what is the advantage of automatic plan correction? Until now, it's one phase, and from now on, it's another phase. Until now, what we have discussed is like you can force a plan, but then I also told you that you also need to monitor it. Now think about it, how much work that is. As a DBA, you have a million things to do, right? Developers come to your cube all the time. Who have time to go ahead and monitor those force plans, right? So it is so tedious. It is really, really tedious. I tried it and I thought that sucks, right? So if you have enterprise edition of SQL Server, please try to at least test it out, the automatic plan correction, right? It is not free. It doesn't work on developer version of SQL Server or other versions, but only for the enterprise. So what happens when you enable the automatic plan correction? Once you force a plan, or you can give that work to SQL Server, because once you enable the automatic plan correction, it will automatically go ahead and monitor. It will not only capture the information, but also monitor the regressions between the execution plans created over time. Let's say there is a plan already and it's running fine. And then there is this new plan that got generated, right? And you are not aware of it. If your automatic plan correction is enabled, it will go ahead and compare the regression, the differences between both of the execution plans. And if the newer created execution plan is working fine, better than before, it will go ahead and force that plan automatically for you. Or let's say there is already an execution plan which is forced, right? And then there is this new one that got created. And there are several reasons why the new execution plan get created. Index rebuilds, updated stats, or if there is some failures within the query store, like we discussed, dropping the indexes, changing the schema of the index that is being used in the force plan. Those are a couple of the reasons why the new execution plan gets built. So in that case, it will go ahead and see if already existed force plan is better or if the newly generated plan is better. If the old plan is itself better, it will keep it as the force plan. It will not change it. It will not make any modification. But if the new one is better, it will unforce the last good force plan and it will automatically force the new one, which is cool, right? You do not have to worry. I mean, monitoring all those things is like sucks, I know. So you can just enable the automatic plan correction by using the Azure portal if you are in Azure SQL. If you are using Azure SQL database, this option, automatic plan correction, is enabled by default. But if you do not want it, you have the ability to turn it off. In the other SQL servers, like by using the Transact SQL, you can enable this as well. All you have to do is alter database name, set automatic tuning, force last good plan to be turned on. So it will always look for the last good plan and it will make sure that plan is being forced. And for this thing to be enabled, of course, you have to enable the query store on the database. So to enable it on the Azure SQL database by using the Azure portal, the first option, like go to the Azure SQL database and then go to the automatic tuning option. It will open up a blade. The first option is force plan, right? So you have three options over there. On is enabled by default. Off, it will turn it off. And inherit means anything that is enabled in the top level as a hierarchy, it will take that as a inheritance, sorry. Let's talk about the query store hints. Any questions, Gavaskar, so far?
Any explanation on query store trace file? They're asking.
Yeah, that absolutely. That will be the last couple of slides where those are the key takeaways. I'll be explaining that in detail.
Okay.
Thank you. Any more questions?
No.
Okay, so let's talk about the interesting topic, query store hints. So query store hints is enabled in the preview mode currently, and they wanted to make it automatic in SQL Server 2022. So knowing query store hints is very useful. So what are these query store hints, right? They are similar to the query hints, but these are something different. These are especially for the designed for the query store. So they design a store procedure especially to use the query store hints. Let's say you have a query, you have a store procedure, and most of your data is good, but sometimes, right, you have those parameter sensitive queries. Let's say most, so 90% of your queries are using one plan, and then there is this couple of parameters that are very sensitive, they use and create a new plan. Let's say you created a store procedure, and then first you executed the store procedure with the sensitive parameter, and it created an execution plan. And then the next time you run with any parameter, of course, it is going to use the same execution plan, right? But then, is that optimal plan? Of course not, because those are the 10% of parameters using that particular plan. Now, how do we fix that? In general, we will go ahead and do that as the recompile option to recompile all the time. But how do we do that without changing the underlying code? That's when the query store hints come in place, where your like if the query is designed by your application or ad hoc query, you do not have to worry about that. By using the store procedure, especially designed for the query store hints, all you have to do is grab the query ID of your query and then place that query ID inside the query store procedure designed for your query store hint, right? And then mention your option that you wanted to choose. So how do you enable that? Execute sp query store set hints. You'll grab the query ID. I will show you how to grab the query ID, okay? Query ID, and then provide the value within the option parameter here, which is recompile. But then recompile is not only the option you have. You can also use the maxstop, recompile, maximum minimum memory grant size, or even the compatibility level. So the next time, once you enable this hint, right? Let's say you enable the recompile option. The next time you run the query, the store procedure, no matter which parameter you use, it will sniff and then it will go ahead and recompile it for you. You do not have to touch the store procedure or the query that is being built by the application. Now let's start the demo. Let me share I think I have to share it back again. Let me share. Where is my demo? Here it is. Okay. So in our demo,
Yes.
we are using, I hope you are seeing my screen, right?
Yes. Yes. It's
Okay. So in our demo, this is a demo centric session, right? Our slides are done because I do not want to go into demo before discussing the fundamentals of query store, I can say. Now you will understand the demo very well because you know the basics, right? So we are using the Adventure Works database here on-prem as well as Azure. So we will see how it works both on-prem as well as Azure. So we are using Adventure Works database as well as Wide World Importers Data Warehouse database as well. So to enable the query store, alter database name, set query store to be turned on. So you can mention what operation mode you want. Do you remember the read write, read only, and off? I would like to place it in read write mode. Let's execute that. So once I executed that, right, I will refresh the database and then expand the database, right? You can see this folder query store, and underneath the query store, you see all of this information. Now let me go ahead and choose the options, right? We have discussed most of these options, but we did not discuss this particular option. Where is that? This one, interval length minutes. Data flush interval seconds is totally different, and interval length minutes is also different. So let's say for every like your interval is 15 minutes, right? By default, it's 15 minutes. So every 15 minutes, it will start a new interval. Let's say I just enable and it will start my first interval, number 1. In that particular 15-minute interval, no matter how many times my query runs, let's say my query is so famous, it will run 40 times a minute. Let's say, no matter how many times it runs, within that particular interval number 1, it will only store one row inside the query store. Because of obvious reasons, right? We don't want to blow up our query store data because we will be mentioning how much max size we want to choose for the query store, right? So let's say it starts the next interval number 2. No matter how many times, it still capture only one row for that particular query. Data flush interval in seconds is like after 3000 seconds, it will flush the data to disk. Sometimes even before that, if there is a memory pressure. Maximum storage MB is 500, right? But you can change that, right? And the most important thing I have to say is like size-based cleanup mode, please put this as auto. Do not turn it off. Now, why I say that is, here we have mentioned the maximum storage size is 500 MB. Once that limit has reached, like once it fill up the 500 MB, your um, your query store will automatically go into read-only mode. It will not capture, it will not throw any alert at you automatically until you choose to. So it's not good, right? If you are placing it off, size-based cleanup mode as off, that is what going to happen. Query store will go into the read-only mode and not capture any information after it is being reached the max storage limit. But if you put the size-based cleanup mode as auto, once the max size limit reaches 90%, it will go ahead and automatically delete the um, the data, old data, until it reaches the 80%. So it doesn't have to go to the read-only mode. It keeps on capturing the information. And maximum plans per query is, this is way too much. I need to change that. But by default, it's 200. But based upon your query information, you need to make sure whether you have to put 50 or 100 or based upon your workload, right? So let's go move forward. I'm going to run these particular options, and then we can also see what all options I have chosen by using the sys database query store options. Once I run this, all the information that we have chosen, the desired state, maximum storage size, interval length in minutes, everything is there. Now let me go ahead and clear up my query store and then clear up my prog cache just in case, because I have been playing before my session. So I want to make sure everything is clear. And let's go ahead and run a couple of store procedures, random store procedure, right? Just to show you how query store will show us. So I'm running the queries, right? Now I'll go to the query store folder and then go to the top resource consuming queries, view top resource consuming queries. And here, if you see, I'll see the bar graphs, something like that. And if you hover your mouse over there and see the query, observe the query, it doesn't provide the parameter value information, right? We have provided certain parameter values. It doesn't show. It will make it as a parameterized view, and it doesn't show the exact parameter value. So I want to see the query itself, right? By viewing it in the grid format. And then if you see here, we have executed two queries, right? The query ID 1 and query ID 2. And you have all the object ID information, object name. And if you see this particular query, different metrics. If you drop down this, you can see all of the metrics that you can capture. And if you hover your mouse on the plan ID, right, it will show you the total duration, average duration in milliseconds, and all the other information. But because we have executed the store procedure, we have query ID 1 and query ID 2. Now, let me go ahead and clear this out first. And then let me run this again. Refresh to see. Yeah. Now I'll go ahead and see what all plans has been captured in my query store, in my plan cache, sorry. So once I execute that, this is my plan cache, right? I'm only filtering on my procedures. So we executed two store procedures. And if you see here, if you hover your mouse over there and see the query that is being captured, right? In the query store, we have seen it as executing as a parameterized query, but here you will see the store procedure itself, right? That's the difference. Now, let me go ahead and clear out my procedure cache. Just now we saw these two, right? I'm going ahead and clearing that out. Now, will also clear my query store? Let's go ahead and see. If you see here, all my queries within the query store doesn't go away. They do persist even after the plan cache is being deleted. Now let me go ahead and clear out my query store. So be very careful to execute this one because all the information that has been captured will be lost. Alter database, database name, set query store, clear. Will clear it out. Now let's see, filter it out and see everything is gone, right? Everything is deleted. Now let's see how this will actually work with the ad hoc queries. So each of these queries, the similar queries, I'm running with the two different parameters and I'm running it twice each. Let me go ahead and run that one and then enable the execution plan, include actual execution plan. I executed that. Now let's go ahead and refresh my query store. Now, if you see here, both are same queries with a similar, um, same queries with a different query IDs, right? Uh, sorry, with two different product IDs, same query. But then as it is a ad hoc query, it will go ahead and create two different query IDs. Now, before that, we executed the store procedure. And no matter how many times you execute the store procedure with any different parameter, it will only create one query ID. But that's not the case um, with the ad hoc queries here, right? Two similar queries, two different query IDs. Okay, now let's go ahead and do something different. I will just add the same 835, the same query here, but then add a simple space, right? Let me go ahead and execute that. Now, will it have the same ID or a different ID? Let's see. Now it has created a different query ID. Now why? It's because ad hoc queries work that way, right? Even a little bit of space, changing the ID, right? Changing the parameter value or adding a comment, anything, right? Anything can make it create a new query ID. That's how the ad hoc queries work. And they will create all of these execution plans and then they will put it in the plan cache and then populate all the plan cache, fill up the plan cache, it will be a mess, right? Think about the query store. It will be a mess as well because if most of your queries are ad hoc queries, that's what will happen, right? And if you choose all option, like in the capture mode policy, instead of auto, if you choose all, it will go ahead and capture all of these ad hoc queries, which is not at all suggestible, right? So that is the reason if you have more ad hoc queries, try to place them and make it as a parameterized thing by creating a store procedure. Place the same query within the store procedure, right? Just like this, I'm just going ahead and creating the store procedure. I created the store procedure. So from now on, we'll use that store procedure. Let me go ahead and clear out my procedure cache as well as clear out my query store before moving forward so that my query store is clear, right? Now let me go ahead and execute the store procedure that we just created, right? With two different parameters, which are parameter sensitive 942 and 707. Enable the actual execution plan on and then execute it. I executed, right? Both are different, right? One does index seek and key lookup, and the other one is doing clustered index scan. Now, why is that? If you see the results, right? The first execution gave 385 rows, and the second one you can see on the bottom of the screen 237k rows, right? Way too different. So when I refresh, as it is a store procedure, it just created one query ID, right? We do not have multiple like before. One query ID, but two different plans. Because they are parameter sensitive, right? They recompiled using a different um, query plan ID. So there are two different plan IDs. If you hover your mouse over there, right? The plan ID number two, which gave us like 237k rows, took total duration of like 1500 milliseconds. But the first one, if you hover your mouse, it just took 108 milliseconds. Now, what if I want to compare these plans together, right? Instead of just seeing one plan each, I want to compare them. All you have to do is click the shift button, click on both the plan IDs and go to the compare plan option here. Where is it? Compare the plans for the selected query, this one. Once you click that, right, it will give you a view of comparing both of the plans and all the properties information. Cached plan size, compile CPU time, compile time, memory, everything, right? Let's say we compared and I would like to choose the plan ID 1 because I felt most of my queries are giving like 350 rows or something like that. Let's say, just for this example, I would like to go ahead and force index seek and a key lookup, right? I do not want clustered index scan. It will ruin my resources, right? Now let me go ahead and I'll close this one. Let me go ahead and force the plan ID 1. You can do that by using the graphical user interface. Let me show how to do it in the graphical user interface. All that you have to do, select the plan ID 1 and then force the plan over here. Force the plan. It will ask, do you want to force the plan 1 for the query ID 3? Yes, I do. Once you force the plan, you will see a little tick mark over here, right? Now, if you hover your mouse, it is being forced. So the next time I execute the store procedure with a different parameter, no matter what parameter I use, I'll go ahead and execute this and it will give the execution plan. Now, did you see? It looks exactly similar, right? Index seek and key lookup, but it may be different as well. It might be looking the same, but it can be different, right? It may not be using the force plan. But how do I confirm that it is using the force plan? By right-clicking the select, go to the properties, and then if you see here, right, use plan as true. When you see the use plan as true, that means it is using the forced plan. Now, if it is not using the forced plan, it doesn't show this option at all. Do not expect to show use plan as false because I don't know, for some reason it doesn't show this option at all. So that's how it will use the force plan. Now, what will I do is I'll just go ahead and alter the database, set the query store operation mode as a read-only mode. I'll tell you why I did that. Let me put that. Okay. But then we force the plan, right? We just force the plan and then we change it to read-only mode. And then I'll go ahead and clear out my procedure cache. Now nothing is there in my plan cache. Okay. Now I'm using the execution plan. I'm running this stored procedure, right? With a different parameter, no matter what parameter we use. Now let's see. Now as we turned it into the read-only mode, will it use the force plan? Let's see. Okay, it executed. Now, if you see the execution plan, it is using index seek and key lookup. And if you go to the properties, yes, it's being used. Now, why? It has turned to read-only mode, right? So it doesn't capture the new information, but it will definitely read already forced plan information and it will use that. Now, what will happen in the procedure cache, right? Procedure cache is completely cleared. We just cleared it out before moving forward, right? So what it will do is it will go ahead and check in the plan cache if there is already a plan. Now there is no plan, right? It will go ahead and create the plan. But in the compilation and the optimization, the recompilation check phase, it will go ahead and see whether the created new plan is similar to the force plan. If it is not, then it will go ahead and create the very similar force plan, right? And it will use it. It will create it. And that is the reason we are seeing it in the properties. It is being used. That's how will happen. Like even though if your plan cache is flushed out, if you already have a force plan, and if your query store is in the read-only mode, do not worry, it will definitely use it. And let me go ahead and turn the query store to be turned off. Okay, that's my first demo. Let me go ahead and show you how I actually use the query store for the database upgrades, right? This is a different database. Now let me go ahead and flush my DPC prop cache, will flush out my prop cache. Now I'm going to use the similar options that we have enable server 2016, right? This is a SQL Server 2016 environment, right? But after they upgraded, I go ahead and place it in the 2012 mode, let's say. So right now my database is in 2012 mode, and I enable the query store. See, right? Now let's say there is this store procedure already there in your environment, but I just want to make sure this store procedure is there. So I created this, right? But this store procedure, let's say it's already there in your 2012 mode. Now let me go ahead and clear out my query store and then prop cache. Now I'll run this particular store procedure, right? We created the store procedure, but then let's say it's already there in your older environment. You migrated the database. You put the database in the older compatibility mode, which is 110 SQL Server 2012, and then I'm capturing the information. I'm executing the store procedure. Now I have to go to a different database, right? So let me go to the query store, the top resource consuming queries, right, into the grid view mode. Now, if you see here, I already captured a plan ID. I already executed, right? The way it used to run, let me close this one, right? So we captured that information. Now I'll go ahead and update that to 2016 mode. We already captured the old mode. So now I'll go ahead and execute, right, in the new compatibility mode. Now I do not know if this query will work better or worse. I do not know that. Let's see. Now let me enable the actual execution plan on execute and see the execution plan. If you see here, it is totally different, right? But then let's go ahead and see here, refresh and see. Did you observe here this plan ID 2? It took the total duration of 8.87 milliseconds, but the new one after the upgrade, it took like 74 milliseconds. I mean, that's not much difference. But if it is causing a problem for you, right? You just upgraded your database. You did not worry about the query store capturing the information in the last compatibility mode, like the older one, and then you just executed the query, and your query is sucking now. It's not working fine. It is very hard in that situation to know how your query used to work in the older version and then making sure it works the same way, right? But the advantage that you have by capturing this information before upgrading your database, see, you have this information. I want the plan ID 2 to be executed. So all I have to do is click on the plan ID 2 and force the plan. Do you want to? Yes, I do. Now the next executions, it will run exactly the same. You might be upgrading your databases, and suddenly your developer comes and say, hey, I do not know what happened, but after the upgrade my query is not working fine. It is taking way too much time, and sometimes it is causing timeout error. What's going on, right? But even before the developers starting to execute the queries or the users starting to using, if you capture this particular information, it is very simple for you to compare both of the plans side by side, right? Side by side and see what's going on with this query. Oh, the old one is used to work fine. So why not I go ahead and force it? That's how simple it is if you take the advantage of using the query store after the upgrades for capturing the baselines. So that's my second one. Let's go ahead and see the third one. This is very interesting because we will see the failures here, right? Not the query failures, but the query store force plan failures. Now again, we are using the query store on the same database, worldwide importers database. Let's go ahead and clear out my procedure cache and set the query store to clear up. Okay. Now, okay, I actually, if you see here, if I press this refresh, because I cleared out, it will go away. But thank God it's still there because I did not press the refresh. Just to show you here. See, the previous query, right? The previous query that we just executed, it is showing like recommended index. Go ahead and create the non-clustered index to have some, performance benefit, right? So now let me go ahead and create that index that they have suggested. Okay, I created the index. Now, if I refresh this, everything will go, right? I just created the non-clustered index. Now, let me go ahead and execute this store procedure and see if it is actually using that index that I created. Okay, enable the actual execution plan on. And then if you see here, it is using the index seek that we just created. Okay, now I like this query because it is using the index that I created, right? Now what I will do is, it is using index seek and the performance is increased. Let me go ahead and force this plan. Force plan. Do you want to? Yes, I do. Now it is being forced, right? Now let me go ahead and do something stupid. Let me go ahead and drop the index that I just created and I forced the plan, right? So it is currently being forced. Now what I'll do, I'll just go ahead and drop the index that is being used by the force plan. Okay, I dropped it. Now I want to go ahead and rerun the store procedure. Okay. Now this is something different. I forced a different plan, but why do I see this? Right? Now if you go ahead and refresh, now if you see this particular store procedure, you see two different plans has been created. No matter I forced a plan, it still went ahead and create this one. Now you do not know somebody deleted the index. Your developer might delete this if he have rights to do, or your other DBA might have done this, right? And then your performance of your query is not working fine. Developer again, he rushed to your cube and say, hey, what's going on? My query is not working fine. It used to work a couple of minutes ago, but what happened now, right? And then you come and see here, what? I forced a plan, but why did it created a new one? Oh, let me go ahead and see what's going on here. So you will go to the queries with the force plan, right? Right click, view queries with the force plan. And if you see here, right, the query ID 6, if you see the force plan ID is 3, but there is a failure. Force plan failure count is number 1. And what is the reason? If you see here, no index. So there is no index associated with that force plan. So that is the reason it couldn't use the force plan. Instead, it went ahead and created a new plan. That's the reason, right? Now, let's go ahead and recreate the index just the way it is. I'm not making any schema modifications. I'm just recreating it, right? And now I'll go ahead and execute it. If you see the execution plan, ta-da, back again, index seek, right? Now, if you go ahead and see here, if you refresh your query, it did not generate any new query in any new plan ID because there is no problem for the query store to go ahead and use the force plan, right? Now I'll do something different now. I will change the schema of that particular index being used by the force plan. All I'll do is I'll add a new column to it, right? Will it do anything? Let's see. I change the schema. Now I'm going ahead and executing the same store procedure one more time, right? Going into the execution plan. What is this? It is using a different one, right? And coming here and then refreshing it, right? It is using the old one which already been created, right? It is using the same old one. It did not create a new one, but then it used the column store index one, right? But then your plan ID 3 is currently being forced. Now wait, what is the reason, right? If you see the reason here, if you refresh, plan ID 3 is currently being forced, but there is a failure. Forced plan failure count is number 2. And what is the reason? No plan. There is no plan associated with that particular new index. And if you keenly observe here, it did not show the force plan failure count reason for the first failure. All it does is showing what is the count, force plan failure count too. But what about the first one? I would like to see the history of the failures, right? It is not shown by default here, but if you would like to get the history of the information, why and what are the reasons, why the history of the reasons of the failures, you need to go ahead and use the extended events. I have created a blog post of how exactly to do it step by step in my website, dbanuggets.com, and go ahead and check for the query store blog post. You can see there. That's how you will know the history of the information. Otherwise, you will not know, right? Now, that's how you will see the failures. Now, your query itself doesn't fail, but uh, the reason will be captured within the query store. And then you can see the same failure information by using the system catalog views as well. Let me close that and go to my next demo. Now, automatic plan forcing. This is very interesting because I will not force anything. It will force by itself, and you will see that live with me, right? Now, for this demo, we are using Azure SQL database, right? So I want to make sure, though my automatic tuning is automatically on, I just want to make sure it is on. So I'm running this query, alter database name, set automatic tuning, force last good plan to be turned on, execute that. Now it is taking time because I have paused my database, Azure SQL database, to save some of the credits because it is very cheap if we pause the database, right? But then once it is paused, see, look at the message. Once it is paused and I want to activate now, um, the first execution will fail, of course, because it is warming up, we can say. And the next execution, I hope it will work this time. Couple of first one or two executions will fail, but then it will work fine. Come on. Okay, let me do this. Let me run on the database. Now it worked fine. Okay, now let me create this particular store procedure, right? The same store procedure that we have been using from the beginning, right? Let me create that. It has been executed. Okay, but then here I would like to show what are the options of this automatic plan tuning. I turned it on, but just to make sure, I would like to see sys database automatic tuning options. By running that, you can see the force last good plan. We just turned it on and all the state information, right? I can see that. And then now I would like to go ahead and free up my procedure cache and then clear up my query store. Now let's create the workload, right? Now I am not going to force anything. It will be automatically be forced by the automatic plan correction. For that to work in this few minutes, we need to run the store procedure multiple times. So I'm running this particular store procedure for 50 times, and this is a parameter sensitive query. Let me run that, right? And let me go meanwhile to the Azure SQL database, refresh, go to the query store. It looks the same. If you see here, this is a Azure SQL database and everything looks the same, right? The top resource consuming queries. Now I have, did you see how fat this graph is? Is because if you see here, the plan ID is really big because that's how many times I executed the query for the 50 times. So let me see in the grid view, right? So this is the query, plan ID, one is created. Now let me go ahead and clear out the procedure cache, right? Because I don't want it to use the same execution plan from the plan cache. Let me go ahead and create the regression. So for the previous one, right, for the previous one, it might have generated couple of rows, but for this one, let's see how many rows it will generate. So we are causing the regression, way too difference between the executions. Now, as a result, if you see here, executing, all we did is just we did it for the 10 times. So it is taking a while to run. Okay. Now, if you see the execution, the count, the number of rows that we got, 237k rows, which is way too much when you compare with the previous execution, which is like 385 rows, right? Now, let me refresh, right? If you see here, the two we have just executed for 10 times, and look at the difference. Like total duration is like 8,680 milliseconds, and this one is just like couple of rows, right? So it took way too less. Now, two of the different execution plans have been generated. Now I need to run the workload one more time so that the query store will have time to compare between the regression and make a decision. Now I'll run the 942, which I executed for the first time. Now I'm going ahead and running for the 30 times. Execute that, right? As it is executing, it's still executing. Now let's go ahead and see, refresh. Now, if you see here, I did not force any plan, right? It has automatically forced the plan ID 1. Now, why? It has compared both of the plans, right? How much time it is taking and what are the duration, total duration, average duration. It has compared itself and it had made the decision. So that's how the automatic plan correction will work. It will run behind the scenes. Now, to know why it has actually chosen the plan 1, you can go ahead and see this particular DMB, says Dmdb tuning recommendations. After executing that, if you see, it clearly shows you the exact reason. So it has to cross the average CPU time, a certain threshold it have to cross. So it has crossed 2.27 milliseconds. Again, this particular threshold is decided by Microsoft, not by us. It is an internal algorithm. So it have to hit that particular CPU time limit, and a particular query should run certain number of times. And then after hitting that CPU time limit, it will go ahead and act on that particular query plan, and it will go ahead and force the plan. It will also give you the query, right? It will also provide you the query of how you can force a plan. If you go to the details over here, right? Let's say I want to show you how it will look like. If you see the details, all you have to do is execute this script. Where are you? This one. Oh, this one. Sorry about that. This one. It has automatically create that for you. All you have to do is execute this one. Or if your automatic plan correction is already turned on, it will go ahead and take care of it. But if you want to see this particular thing of recommendations and you want to do it by yourself, you can do that as well. Now, let me go ahead and close that as well. And then let me go to my last demo, query store hints. Now, how does the query store hints work? Let's say we have a query, right? This is the store procedure. Again, we are using the same query, same store procedure. I would like to go ahead and connect to my Azure SQL database, right? I want to execute and create this particular store procedure, right? Now, let's say I have freshly created a store procedure, right? And then I'll clear out my procedure cache and the query. Let me do that in the database. Let me do that. Okay. Now, these two parameters are very sensitive. Okay. Let's go ahead and execute that by enabling the actual execution plan on. Execute that, right? I executed that. And if you see the execution plan, the first execution, right? How many rows did we get? 360k rows. So that is the reason it decided to do the clustered index scan here. That's fine. But what about the second one? If you see here, the second one is 385 rows. Now, do it really need to do the clustered index scan? No, right? But why did it use the clustered index scan? Is because the first execution after creating my store procedure, the parameter that I passed for my first execution ever has created this one, and the next execution No matter what I use, what parameter I use, it will follow the same thing, right? Until I flush out my plan cache or something like that. Is that right? No, this is a parameter sensitive query. Now, if you are not using the query store, what do? You'll just go ahead and do a recompile, right? But then we need to change the code underneath. I don't want to do that. I want to use the query store for that. So how do I find the query ID to use the query store store procedure that they especially designed for the hints by using this query, right? I'll share my slides and all my demos so that you can copy this over or you can go to the link over here. So I would like to grab that particular query ID. I'll execute that, and then that is a query ID 1, right? Now all I have to do is execute sp query store set hints, give the query ID 1, and what value are you going to pass? So in the option parameter, I will choose recompile. From next time, after executing this particular store procedure, I would like to use recompile, right? Now, what I will do is, what hints are currently enabled? I enabled the recompile hint, right? Now you can see what all are enabled on your queries. By using this particular system catalog view, I'll execute that and I will show you. Now the query hint ID 1 is being used for the query ID 1. And what query hint did I use? It's the recompile option, right? Okay, now I use recompile. Now let me test it. Now rerun the store procedure over again to see whether they are activated immediately, right? Execution plan. Now if you see, right, I rerun the same one again. The first one gave me like 360 carrots. The second one is 385. But here, if you see the difference, right? How beautiful it is. The first one, it took clustered index scan. The second one it doesn't need to do the clustered index scan because the rows we are getting are way too little. It did index seek and keylookup. It just went ahead and recompiled. You did not have to change the code, right? Now, let me go ahead and use a different hint for the same query ID1. I'm updating that from recompile to max dot 1. So let me go ahead and run that. But then if you go ahead and use here, what are my query hints currently? If you see the results, it will say the query ID hint 2 is being currently used and it updated from um, recompile to max dot 1. But again, it is not providing the history of the information. If you see, again, to do that, you need to use the extended events. So the query ID hint is currently 2. This is 2. So let's go ahead and execute and see whether it will actually use the query hint, this particular max top one. Now, once I update that, right, it will go ahead and stop using the recompile. Did you see here? Both of them are using clustered index scan. And then if you see here, it is using the max top one. If you go to the properties, and then now I have to figure it out. Where is this max top option? Come on. So it will use the max top option. Come on. I always have trouble to find where is this max top. So it should be somewhere here. Max top set to 1 here, right? The max top is set to 1, but then it is using the it is not using the recompile. What if I want to go ahead and use both of them together? I can also do that, recompile and max top 1 together. Now after doing that, right, if I go ahead and see the query store hints, what all my hints, in the results you'll see the updated information, right? Currently it is using option both of them. Now let me go ahead and run again. Let me go ahead and clear out my cache first and then run this over again. So if you see here, so nice right now. It is both using recompile, right? It created 2 different execution plan. And then if you go to the properties, it is also using max top 1. And even for this, it will go ahead and use for both of them, max top 1 and recompile option. How nice is that? So if you want to delete, right? delete and clear out all the hints. Execute sp query store clear hints and give the query ID 1 because we are working on the query ID 1. It will clear out the hints. And if you go ahead and check what all hints are there for your queries, we were using only query ID 1, right? So it will clear it out. And again, for all the supported, what all hints will be supported for this query store, go to this particular link or even go to the Microsoft. So I think I'm done with my demos, and let me go ahead and see the most important stuff. So what are the exciting improvements in SQL Server 2022 then? So in SQL Server 2022, automatically, if you are creating a new database on SQL Server 2022, then your query store will be automatically enabled. But if you want to migrate your existing database from 2016, 2019 to 2022, then it will not affect, it will not automatically enable. You need to manually go ahead and enable it. And until now, the query store doesn't support your availability group for the read-only replicas. It will not capture the information on the read-only replicas. All it does is it will capture the information on the primary replica. That's all it does right now. But in 2022, they are also going to support that information. But then we need to know how that information is being captured. Where, like, will it use the other database to capture the information, or will it use the same database? Because it is read only, how can it do that, right? So what does it do? Will it capture that information on master database? I'm not sure about that, right? We have to see how it will use. Maybe I have to download the latest release to identify how it works. Okay, so the next thing is they also try to use um, the feedback cycle information, which is associated with max stop and cardinality estimation information to improve the performance of your queries as well. Those are the three main improvements, especially in the query store. So we came to the end, but these takeaways are amazing because all the session that I have discussed is one one thing, and these are the other thing because these are really important to know and why we have to choose what. So let's see. So the first key takeaway is you cannot disable query store on Azure SQL database single database or Elastic Pool. You cannot disable that. It will fail. So the trace flags that the other attendee was talking about, now is the time. So let's talk about this particular trace flag and what does they mean. Trace flag 7745 helps to avoid the query store data to disk before SQL Server shutdown. So what does that mean? You enable the query store, right? You enable the query store and you did not enable any trace flags. And then you wanted to restart your SQL Server. But you have databases where you enable the query store. So when you restart the SQL Server, the first thing that will happen before restarting is all the information that has been captured by the query store in the memory needs to be flushed. Give me a minute, I'll drink some water. Sorry about that. I have been speaking since long time, right? So I need to have some water. So the trace flag 7745, if you have to restart the SQL Server, all the information that is being captured in the memory has to first flush out to the disk before even thinking about the restarting SQL Server. Now, if you have critical SQL servers where you do not want to wait, enabling the trace flag 7745 will actually restart immediately, and losing the data is the thing that will happen here. So if you are okay, if you are okay to lose that information that has been captured in that interval, then it's a it's a good thing to go ahead and enable the trace flag. And the other trace flag 7752 is at the database level. So if this trace flag 7752 is not enabled, what will happen? Um, if you want to like take the database offline and thinking of take it online, or if you want to restart the SQL Server, right? If you do not have trace flag 7752, the first thing that will happen once the database, even before the database is coming online, is if you have the query store already enabled for the database, there is certain system information that should be pushed to the memory even before the database gets into online. But it might take some time to flush that information to the memory, the system information into the memory, right? And you do not want that. You definitely don't want to do that. By enabling this trace flag 7752 is like you're saying to SQL Server, okay, take my database online first, and then take the system information into the memory later, like asynchronously. So users can connect, they can do the work, and then query store can do its work on its own. But then until the system information is being moved to the memory, the query store will be in the read-only mode. That means it can use the force plan information, but it cannot write until it moves that system information into the memory. That is related to 7752, but it is enabled by default in SQL Server 2019. This particular trace flag 7752. So if you are on a lower versions of SQL Server, you do not have to think about it even. You can just go ahead and enable it because it is by default on 2019, right? And if you have natively compiled store procedure, right? Uh, these natively compiled store procedure is like, I'm not like 100%, but those are the computerized information that will be placed in the DLLs so that the CPU can directly go ahead and execute these queries. Those are called the natively compiled queries. If you have natively compiled queries, and if these queries natively compiled queries are not like the general queries. They don't go to the compilation and the optimization phases. They directly be executed through DLL um, by the CPU. So if you have those queries, right, enabling sys.sp xtp control query execution stats will be helpful if you have these queries because they doesn't capture by itself. You need to enable that. And this particular information that is being captured for the native compiled queries will not be persisted. And on every SQL Server restart, they have to restart the information as well. And if you have many ad hoc queries, right? Too many ad hoc queries, use optimize for ad hoc workloads option to save some cache memory. And the maximum number of plans per query is by default 200, but according to your workloads, please decide that one.
It's really useful when you're working with.
Sorry.
Hello. You can continue. Hello. Hello.
Maybe they are talking to somebody else. Maybe. Okay, I'll be continuing. If the maximum storage size MB is reached, right, and your automatic cleanup policy is not enabled, it is off, then your query store will automatically goes to the read only mode. It doesn't capture the new information. And if your size based cleanup mode is turned auto, then once your max size reached 90%, it will go ahead and clean up the old data, like the ad hoc queries information. That will be cleaned up until it reaches the 80%, so that your query store doesn't have to go to read only mode. And the other one is like if you are in the auto mode, which is by default in the latest versions of SQL Server, if you are 2016, please turn it to auto mode because by default it's all and not auto. You need to change that. So if you put it auto mode, then it will avoid the ad hoc queries with small resource consumption. By default, you do not have to worry about it if you are in auto mode. And your query store, like the query store capture mode is set to auto, which is recommended, and it is by default in SQL Server 2019, Azure SQL Database as well. And there is this GitHub link, and a QDS toolbox is a collection of the queries, the collection of the catalog views, like the queries where they will query the system catalog views to capture the necessary information from the query store. They already designed that, and it is completely free, and they have written by the channel advisor. You can go ahead and download that, and you can go through the different queries, how you can capture the information, retrieve the information from query store. And if you have, I know many people have this question, but what about the performance, right? Will my performance sucks? And sometimes my query store gets full, and then those are kind of queries. If you have those kind of question, there is this very nice blog post, especially for the performance overload questions, by the Erin Stilato. For when she used to work for the SQL skill, she have written a blog post. Go ahead and look into that. And to learn more, like I said, dbnuggets.com is my website. The last link over here. I have this is like my blog post are the extended version of this particular query where I have gone through the in-depth information, like how can I capture the failures, right? The history of the failures by using the extended events and whatnot. There are so much of information, especially for the query store. You can look into that as well as the Microsoft Docs. And these are the other resources I followed to prepare this presentation. And I would like to thank you, Gavaskar, for giving me this wonderful opportunity. I know I have taken a lot of time, but I covered a lot of content as well.
Yes, that's fine. Yeah.
Thank you
Again,
so much for the
yeah.
opportunity.
Again, on behalf of multi-cloud for you, we'd like to thank Deepti. He has covered a lot of topics, and without any ado, I am moving to the certification desk. So we are going to provide a level 1 certificate for all the participants who are attended the session. So let me share my screen. So this is a secret code which you got to provide in the private dashboard. Once you provide your email ID and the username, you will be taken to the private dashboard. So this secret key you can provide. It will ask the secret key over there. You can provide this secret key and you can download the certificate. So just I will share it in the chat. And this is a certificate which you can download after providing the secret key which we have provided. And just I will explain how to download it over here. So already we have shared the shared the link of this particular session. So you can provide your name over here. So now I am providing my name over here. Yeah. So you can provide your email ID and your phone number, and just you click register. So now this is a private dashboard, and you can see the live streaming of this particular session in YouTube, and you see this is the link which is provided, claim certificate. Just you click it over here. Yeah. Now it will ask your name which has to be printed in your certificate, and your email ID. Just you check it over the terms and conditions, and next you provide next, and then you put your key over here. Okay, the secret key which is set S57LI, and click next. And once you submit it, so certificate will be generated and it will be mailed to your email ID.
And can they upload that to the LinkedIn?
Yeah. They can upload that. Okay, they can upload. You can directly upload to the LinkedIn also. Okay, this I will explain that again. Yeah, already I have downloaded the certificates. Yeah. is one of the mail ID from which I download the certificate already. So you can claim the certificate. Okay. Yeah. So I had to check my mail. Yeah. The certificate, we can download the certificate from this link. Okay. Yeah, and you can share it. Okay, this link you can share it in the in LinkedIn or any other social media platform. You can share it. Okay. So that's all from the certification desk. If you have any issues in downloading the certificate, just you can send the issue in the private dashboard or from the Telegram or by the Telegram link. Okay. So so that's all. Yeah, Dipti, shall we unmute the participants for asking any questions?
Yeah, sure. Sure.
So participants, you can ask any questions. You can by unmuting yourself.
Hello, Dipti. Thank you very much for this wonderful session. Saminullah here. So I just wanted to confirm if this entire recording is can be accessible after this session as well, because few of the parts I've missed out from the session. So I just wanted to cover it. Please suggest. Thank you.
Gavaskar, do you need to
Yeah.
answer that question?
Yeah, it is accessible. I will provide this link within next within 24 hours. We will upload this video in this link. Okay, you can access the recorded session in this link, which is provided.
All right. All right. Thank you very much.
Okay.
Feedback for me?
Dipti, I have one query. Can we enable the query store for the bigger database like a 10 TB or 11 TB database?
Yes. But please make sure to know the options very well. Like how much size you are placing for the query store, because that is a huge database, right? So you need to make sure you have enough space for your query store information, like max size, and you need to make sure it's only auto, and then the cleanup policy is need to be auto as well. You need to make sure the settings are proper. Otherwise, you will see a couple of things that you don't want to see. Like once it hits the limit, it will go to the read-only mode. Those kind of things. Like getting the better idea about the options will be the go, I can say. But it is definitely it will be an option because in 2022 they are automatically enabling it on every single database.
Okay, because currently we are in the 2016 version, so I'm just thinking because there was some performance issue of my database post
Mhm.
migrating from 2014 to 16, but
Mhm.
still I'm working because we're to implement. I mean, after migrating 2016, there was a couple of performance issue. What we have done to for a quicker work down is just enabling that cardinalities or on.
The latest ones, right? Right.
Yeah, but we made it off. That one is because of which you can use the previous version cardinalities.
Yeah. So on certain queries, the older cardinality estimates works fine, like work well than the newer ones. But
Because my
I can already, yeah.
yeah
Go ahead.
yeah just I want to check because my size is big and there are the thousands of transactions hits per minute to my database. So in that
Right.
case, how can I estimate what would be the max size of my query store?
The max size, you have to test it out, Praveen. We can't necessarily say like because it all depends upon the workload, how many times your query is running, and what are the what are even the compilation. It has to hit certain limit, right, to be even captured. Even though if you put it on auto mode, you need to test it out. I can say that.
Because why I'm asking because most of the things the no production and the non-production may not be identical to check the workloads as well.
Right, right, right,
Yes, sir. In
right.
those
But
cases, it
then
would be
you
very tough. Yeah,
right, I understand. And then even though you take the backup copy and restore it somewhere, you don't know the workload, right? How mu-
exactly.
how it is sitting. So you
Yeah,
need to test it out, move it, just increasing, but you need to be ready to increase the size of your query store, right? You
because
can
why?
change that.
Yeah, yeah.
By default, it is 1 GB, but in your scenario, I think you definitely need to increase that.
hmm Because why already we are facing the performance issue. On top of that, we are applying the query store because the query store also sits on the same primary data file where my database sits.
Right.
Will it will it increase? I mean, the problematic will it be increased it or how it will be? Because
Mainly the
both are
query
sitting on
store.
the same. Yeah.
Right, I understood. You can't change the primary, you can't change where it is actually capturing. You can't change that. So definitely in your scenario, you need to definitely test it out. You need to, as the queries are hitting the database, and you can see the flow of how much it is capturing, and based upon that, you need to increase the size of the queries, the max size limit. You need to increase that. And if you think, oh my God, it's not working, and the monitoring tool is better for us, then I think you can also disable that.
Will you
You
suggest
know,
any of the monitoring tools which helps this type of information? I mean, even to analyze the workload as well. Suppose that today my workload is less. After that, I am putting some workload from different server to this server, and maybe application team ask, can you identify how much workload can be increased has increased on this?
yeah,
In
there are certain tools where I don't remember on top of my head, but there is this tool. Oh, I don't remember why I'm using it currently, but still, um, it will capture the information like all the way from the application till the database. But within the database,
maybe it's
there
not
are
because maybe
many
the
tools,
workload
right?
is increasing it. They may ask it how much
Right.
workload has increased in the last week to this week.
Right. I think that is available everywhere for the database monitoring tools like DPA. We are currently using DPA and it is very helpful.
What is that?
SolarWinds, DPA meaning SolarWinds.
Oh, solar winds.
We are
Okay.
using, yeah, we are using SolarWinds, and it has helped us a lot in certain scenarios where the queries are working terrible. and certain suggestions that it provided, like if you create this index on this particular query, it has this much performance, and we tried to do it and it really worked. And I'm sure the other participant might also have several other suggestions as well, but from my side, I use DBA.
Okay. Without the tool, can we identify the SQL
Oh, it's
workload?
very tough. It's very tough. It's very tough. All you can do is go ahead and see the plans in the plan cache, but then that is not consistent, right? The plans get evicted, and it is very, very difficult for you to even see the execution plans that are being created over time. Um, all you can do is the latest plan that is in the cache. That's all you can see.
Because
And then
this
the
type of
indexes,
questions for
index
my
recombination.
application and as well.
Right, right. You need to use, if you do not want to use the query store, the other option that you have to performance tune your things is the monitoring tools, right? At least you'll know like what are the top resource consuming queries. You can
Mhm.
also monitor by using the extended events, uh, the resource consumption, what is the resource consumption, and if it hits that limit, it will capture that. Extended events have very much less performance um, overhead, I can say, but
Oh,
it's about how we are setting it up.
options.
Okay, the question from Mani Kumar is the title of the session is Azure Query Store, and it's all about mentioned about. No, no, no. If you have looked into my demos, half of my demos were in the Azure SQL database. I did not use the Azure portal, but I used the Management Studio, SSMS Management Studio, to connect to the Azure portal. If you remember, like if you'd like to see it again, I think Gavaskar has provided the link to look into the video recording. You can see it later by yourself. Yeah, yeah. I have provided the GitHub repo of mine. I'm providing it again over here. You can go there. My older version of Query Store is already there. It has the same demos, but then I added more content to my slides this time. So I'll be uploading the new slides to the GitHub as well. You can just either flag that page, or like, I don't know, you keep that link safe so that. uh, Mary says, like, I will also write a review about how excellent this experience was. I'm so thankful that you felt that way, Mary, and I really appreciate. Um, I just thought of sharing all the knowledge that I learned. So I think this is helpful to you all to attend the session. Any more questions for me before I hang up? I mean, you can follow me on Twitter, or you can send me the friend request on LinkedIn. You search by my name, Deepthi Goguri. I'm very active on LinkedIn and Twitter. I'm not on the other platforms. I'm sorry. I'm not on Facebook and other Instagram. I don't waste my time. So at least regarding the social media type. And I'll watch movies and all, but if you want to contact me and then know what all I'm speaking about next, I'm going to present on the topic in coming months. I'm going to present on the security in Azure, where I will go to the layers of security and how to implement each one of them. Like if you are interested, like contact me on Twitter or LinkedIn. Have my connection. I'll just accept yours too, and it will be an honor to connect to you.
Deepti, this is Saikam. I've been following you from many days. This is a wonderful session from your side. We are waiting for more session from your side. So it's a great experience. I mean,
Are you
knowledge
Narendra?
sharing. Yeah.
Hey, hi Narendra. He's my buddy. He's my buddy. He's my friend. And he's pretending like he's
I'm very proud of you. I feel like
okay.
it's very, very good, very excellent session, I can say. Thanks
He
for sharing.
provided his last name, but then I recognized
Thank
you,
you.
buddy.
Thanks for
Yeah.
recognizing. Yeah.
Thanks for
So,
attending. Thanks for attending. I hope it
yeah.
is
Thanks so
useful.
much. Sure. Thanks so much, Deepti.
Any more questions for me? Thank you so much. Yeah, and also, I just want to put shameless plug in here. I started a series on Quick Track for Azure beginners for the beginners of Azure SQL, something like that. But that is a different. If you read that blog post, my first blog post on Azure for beginners, it's a quick track. Now, why I say that is a quick track is because when I started learning Azure, it's like too much, way too much overwhelming to me to read the number of resources. I mean, Microsoft has too much documentation, like Microsoft Learn has like way too many modules, and I'm lost while I'm going through them. And I thought it would be really helpful for other readers who read my blog post. Um, because that's a curated one. All the in my own words, whatever I learned, I put it in a table format, and I made sure people learn very quickly, and they don't have to forget things right while they read. So I thought of curating that information and in my own style, right? And I released my first blog post on that, and it was a huge success. Now, why I say that is because looking at the views, the number of views I have, it's like I never had those many number of views for my any of my blog posts. So I thought, oh, who will read this? I thought that way, and I stopped for a couple of months. I did not create. I had the idea, but I thought, who will read? Because there are already out there so many resources. But then it's a success, and I am going to on that's a blog series that I just started 2 days ago, and it is going to be a very big series. As I learn, I will create the blog post and I'll release on the LinkedIn. Like if you want to follow me, I'm not like asking you to follow me, but then if you want to see those kind of content, more of those, you can get the, like, as I release the blog post, you'll get the notification to your email. Like if you go ahead and subscribe to my uh, blog. If you don't want that, if you are on my LinkedIn, then you can also see it there, but then you will not get notified. Yeah, sure. Mhm. Mhm. Yeah. Yeah, and also I have a session on Dmdb. Like if you want to know how Dmdb works and what are the options that you have, like Dmdb is way too trouble, right? So if you want to know in-depth knowledge on Dmdb, I have presented a session in Group by. So just go to the YouTube and search Deepthi Goguri. group by, you'll get my first link there where I presented on Dmdb. So that is a in-depth session on Dmdb. You can go ahead and look into, or just type Deepthi Gogor in YouTube. You have several other resources, like all my presentations will be visible to you. You can go ahead and look into as well. Any more questions for me before I hang up?
Yeah. So, shall we wind up?
Yeah.
Yeah. Okay. Again, once again, on behalf of Multi-Cloud For You, would like to thank Deepthi for giving a wonderful session on for Azure Query Store. It is very informative, and it's a little bit lengthy session, but it is more informative.
Yeah,
Thank you,
it is a
Deepthi,
lengthy
again.
session
Yeah.
answer. And then when I create the Azure security module, right? When I
Yes.
create that session, I'll let you know. I'll present one more time because I see the participants, they are like really interested. They are hanging in there and then listening to the session. So I think it will be useful for them.
Yes.
Yeah.
Okay.
Sure. Thank you all.
Thank you.
Have a great
Thank you,
night. Have a
participants.
good night, everyone. Yeah. Sure. Bye. Thank you so much, Gavaskar, and the
Thank
other
you.
hosts
Yes.
as well. Bye. Bye.